Welcome back to AI.Code.Cast for another deep dive, and today we're tackling a SQL challenge. One that looks deceptively simple at first glance.
Yeah, it's the kind of problem you might encounter on coding platforms like LeetCode or maybe even in a technical interview.
Oh, for sure, for sure. And it all hinges on something that can trip up even seasoned coders, NUL values.
Right, NULL values in SQL, they're known for causing unexpected behavior if you're not very careful.
Absolutely. They're not quite zero, not quite an empty string.
Mhm.
They've got their own special rules.
Exactly.
So let's break this down. What's the specific problem we're diving into today?
Imagine you're working with a customer table in a database.
Okay.
Each customer has a name and a refereed if they were referred by another customer.
Gotcha.
But here's the catch. Some customers might not have been referred by anyone, so their refereed is NUL.
So we're dealing with missing information, which is pretty common in real-world data sets. What's the challenge here?
The challenge is to write a query that finds all customers who are not referred by a specific customer. Let's say for this example, we want to find all customers who are not referred by the customer with an ID of 2.
Okay, sounds straightforward enough. Couldn't we just select all customers where the refereed is not equal to 2?
That's what most people would think. And it would work perfectly if we didn't have those NUL values.
I see where this is going.
But here's where the NUL trap comes in. In SQL, comparing anything to NUL using not equal to doesn't give you a clear true or false.
Okay.
The result is unknown, and the database doesn't treat unknown as true.
I see the problem. So our simple query would miss all the customers who don't have refer at all because their refereed is NUL.
Exactly. It shows why handling NUL values correctly is super important in SQL.
Okay, all right. So our initial approach hits a snag.
Yeah.
How do we get around this and make sure we're not excluding those customers with an NUL refereed? What's the first solution that comes to mind?
Well, think about what we're trying to achieve. We basically need 2 conditions to be met. Either the customer's refereed is not 2 or it's NULL.
Wait, I think I'm getting it. We could use the OR operator, right?
Mm-hmm.
So the query would select customers where the refereed is not equal to 2 or where the refereed is NUL. That way we cover both scenarios.
You got it. That's a common and effective way to deal with NUL values in SQL. By explicitly including the IS NUL condition, we're ensuring that customers without a referrer are included in the results.
Okay, that makes a lot of sense. So in our pseudocode, we basically say something like, select all customers where the refereed column is not equal to 2 OR, where the refereed column IS NULL.
Exactly. That's the essence of the OR solution. It's simple, straightforward, and it addresses the way SQL handles comparisons with NUL values head-on.
Yeah, it's a fundamental technique that seems applicable in a lot of situations where you're dealing with data that might be missing.
For sure.
But I've seen some other solutions to this kind of problem that use functions. Did any of those come up in this case?
Yes, actually, one approach that stood out used a function called COALESCE.
Ooh, COALESCE. I've heard of that one, but I haven't used it much myself. It sounds fancy. What does it do?
COALESCE is all about providing a fallback value when you encounter a NLL. Imagine it as a way of saying, if this value is NLL, use this other value instead.
So how would that work in our customer referral problem? Walk me through it.
Sure, we'd use COALESCE on the refereed column. The first argument to the function would be the refereed itself.
Okay.
If it's not NLL, COALESCE just returns that original value.
Gotcha.
But if it is an NLL, that's when we provide our second argument. And this is our default value, something that wouldn't normally appear in the refereed column.
Okay. Let me make sure I'm following. So if a customer has a refereed of 1, COALESCE would just output 1. But if the refereed is NLL, we could tell COALESCE to output, say, 0 instead.
Right.
Assuming a 0 isn't a valid refereed in our data.
Precisely. And that's the beauty of COALESCE.
Okay.
We preemptively replace those NLL values with something we can reliably work with. Then we apply our not equal to 2 condition, knowing we won't run into those NLL comparison issues.
So in pseudocode, we'd say something like, for each customer, apply COALESCE to the refereed, replacing NULL with 0. Then check if that output is not equal to 2. Am I getting that right?
You nailed it. It's a clever way to handle NULL values concisely.
This is making a lot more sense now. I'm seeing how COALESCE can streamline things. But before we get too deep into the specifics of this solution, let's take a step back and explore some other approaches. Are there any other ways we can solve this problem?
Well, there's another way we could tackle this. And it uses a subquery to filter out customers referred by customer ID too. It's a bit roundabout, but it shows a different angle to the problem.
Oh, subqueries. They can be powerful, but yet sometimes they make my head spin. How would that work in this case?
So the idea is we first write a subquery. That subquery selects all customers who do have a referee of 2.
Okay.
That gives us a subset of customers we want to exclude from our main query.
Gotcha. So it's like a helper query identifying those customers we don't want in our final results.
Exactly. Then in our main query, we select all customers whose IDs are not present in the results of that subquery. We can do this using the not-en clause in SQL.
Okay, so it's kind of like reverse logic.
Yeah.
We're not directly picking customers who weren't referred by customer 2. We're finding everyone else and then filtering out those who were.
That's a great way to put it. And it would technically give us the correct answer, but this approach has some potential downsides.
Oh, what kind of downsides?
Well, for starters, it can be less efficient than the OR or COALESCE solutions we talked about earlier. The database has to work harder to execute the subquery first. Then it compares every customer's ID against that temporary set of results. It can be a lot of overhead, especially if you've got a large data set.
Right, so while it works, it might not be the best performer in a real-world scenario. It's a good example of how the most obvious approach isn't always the most efficient.
Absolutely. It reminds us to always think about performance, especially when dealing with large data sets.
You said earlier this subquery solution shows a different way of thinking about the problem. What did you mean by that?
Sometimes when you reframe the problem, you get a new insight or solution.
Okay.
In this case, thinking about finding customers referred by customer 2 and then excluding them, that might lead to a different approach than thinking about finding customers not referred by customer 2 directly. While this subquery solution might not be the best for performance, this kind of outside-the-box thinking can be helpful in other situations.
So it's a good brain workout, even if it's not the most practical solution for this scenario.
Exactly. Now back to our more efficient solutions. The OR approach and the COALESCE approach, they both handle that NULL value challenge.
Right. Let's take a closer look at each one. With the RR approach, we're essentially saying select all customers from the customer table where the refereed column is not equal to 2 OR, where the refereed column IS NULL.
Perfect summary. It makes sure we're including customers with a different refereed and those with no refer.
In the COALESCE approach, we were talking about replacing those NULL values with the default.
Yes. With COALESCE, we replace NULL values with a default value like 0 before comparing. So the pseudocode would be something like, select all customers from the customer table where the result of applying COALESCE to the refereed column, replacing NULL with 0, is not equal to 2.
So we're sort of cleaning up the data before we apply our filter.
That's one way to look at it. COALESCE helps us avoid those tricky NULL comparisons by making sure we've got a concrete value to work with.
It seems like both the OR and COALESCE are good solutions. But is there ever a reason to choose one over the other?
Great question. Both are valid and will give you the right answer. But there are subtle differences that might make one better in certain cases.
Okay.
Let's start with OR. It's clear and easy to understand, which makes it good when readability is important.
It's definitely very clear about what it's doing. Those are prizes.
Exactly. COALESCE can be a bit more concise and might be a bit more efficient in some cases. Because it lets the database process the query in a single step without having to evaluate different conditions.
So if you're dealing with tons of data where performance is key, COALESCE might give you a slight edge.
Possibly, yes. But it's always a good idea to test both approaches with your specific data and database to see which performs better.
Right.
Performance can depend on things like data size, table indexing, and the database engine.
It sounds like COALESCE is a handy tool for those performance-heavy situations. But honestly, both the OR and COALESCE have their strengths, and choosing between them comes down to personal preference and the context.
I totally agree. The important thing is to understand how NULL values work in SQL and have different strategies to deal with them effectively.
Right. So we've looked at a few ways to tackle this NULL value challenge in our SQL coding problem. We talked about the OR solution, the COALESCE solution, and even that less efficient subquery solution. But before we move on, I think it's worth revisiting COALESCE and highlighting how versatile it is.
Okay.
We've been focusing on replacing NULL values with 0 in this problem. But is that always the best choice?
That's a great point. The default value you pick for COALESCE depends on your problem and the data. In our customer referral problem, we assumed 0 wasn't a valid refereed. But that might not always be true.
Imagine if 0 was a valid refereed, maybe representing customers who signed up through a specific campaign. Using 0 as our default could lead to wrong answers.
Exactly. You always need to think about your data and choose a default value that won't cause errors or mess up your results. And it should make sense in the context of your problem.
So if we couldn't use 0 less, we could use any other value that wouldn't clash with our data. right? Maybe -1 or 999 or something that's unlikely to be a real ref read.
Exactly. The key is to pick a value that's outside the normal range for that column and wouldn't be mistaken for real data.
That makes sense. It's a good reminder that understanding your data is just as important as knowing the technical details of SQL functions.
Absolutely. And to add to the versatility of COALESCE, it's not limited to numbers. You can use it with strings dates or any data type.
Oh, interesting. So if we had a column for customer emails and some were missing, we could use COALESCE to replace those NL values with a default string like no email provided.
Exactly. That way your reports and analysis are consistent and don't have gaps because of NL values.
COALESCE is starting to feel like a Swiss Army knife for missing data in SQL. It's a powerful tool.
It is. And it's just one example of the many functions and techniques in SQL for managing NLL values. The key is to be aware of the potential issues with NLL values and pick the best approach for the problem you're solving. Sometimes a simple OR condition is enough, while other times a function like coalesce might be better.
This has been a really interesting deep dive. I feel like I understand the complexities of NLL values in SQL much better now.
Me too. It's always good to go back to these fundamental concepts and see how they're used in real-world situations.
We've covered a lot today, from the problem itself to different solutions and even potential pitfalls. But before we wrap up, I think there's one more takeaway for our listeners.
Absolutely. I think the biggest thing is to always be mindful of NEL values and how they can affect things.
Right. Like just assuming NLL acts like 0 or an empty string can lead to some really annoying bugs and inaccurate results.
For sure. You might write a query that seems totally logical, but you end up missing important data because of those hidden NLLs.
Exactly. That's why we spent so much time on different ways to handle them. Like the OR approach is great for explicitly including NLL cases, and then coalesce lets you replace those NLL values with something you can work with before doing comparisons.
Yeah, it's like having different tools for different situations.
Yeah.
And remember we talked about that less efficient subquery approach?
Yeah.
It shows that even if a solution works, it might not be the best way to do things.
Right. Efficiency matters,
Yeah,
especially with lots of data. Those milliseconds add up fast.
definitely. And it's not just about speed. Clear and concise code makes your queries easier to understand and maintain later on. Which brings me to something we haven't really talked about.
Okay.
What if you need to know that a value was originally NEL for your analysis?
Well, that's a good point. It goes back to understanding your data and what you're trying to achieve with your analysis. If you need to keep track of which values were and NUL replacing them, might not be the best way to go.
Right.
You might need a different approach, like using some logic to handle NULL and non-NUL values separately.
Exactly. You could have a flag or a separate column to mark those cases.
Right. So even though we focused on these specific solutions today, it's really about the bigger idea of NUL handling and adapting it to what you need.
Couldn't have said it better. It's like having a toolbox. You need to know what tools you have and when to use the right one.
Well said. So to everyone listening, don't be intimidated by NUL values in your SQL code.
Yeah.
Take a breath. Remember what we've talked about and pick the approach that works best for you. And who knows, maybe you'll come up with some new tricks of your own.
That's the fun part of coding. Always something new to learn. Thanks for joining us on AI.Code.Cast. We'll see you next time for another deep dive.
Happy coding, everybody.